So thank you for joining us today. I'm Brooks Patrick. My role at Esri is actually out of our European office in Rotterdam. I'm the business development manager for the sector, smart city sector. We focus on new products like ArcGIS Urban and CityEngine, and predominantly are talking to cities about urban planning and making use of 3D capabilities and technology in urban planning. I work a lot with the R&D center here in Zurich, so I was in town. I thought maybe I could share some of the work that's been going on at Esri and also around Europe related to digital twins and making use of digital twins in a more, let's say, consolidated strategy towards urban planning. And yeah, for those who don't know, I mean, a lot of the technology that I'll be talking about today, whether it's the 3D technology at the core of ArcGIS, or if it's ArcGIS Urban or CityEngine, it's all developed actually here in the Zurich R&D Center, which is exciting because it's all European software at the end of the day. So I will go ahead and get started by asking the room a question. I know for those in the recording, you might not know, everyone came back from lunch, so I'm now going to give them all a test. So what is a digital twin? Everyone probably came to the room with a different idea of what a digital twin is. Probably some of you are thinking 3D model, some of you thinking maybe automated IoT for manufacturing. It can be a lot of things, and it's both useful as a marketing term, but there is also something quite tangible about digital twin, that idea of creating a virtual representation of reality in order to run scenarios, to do testing, to actually track processes. So I'll just poll the room briefly. And there are two choices here. It's not a test, really. It's just your preference. So think of this as your preference. There's no right or wrong answer here. But the choice A says digital twins are primarily about 3D technology and data, as well as immersive experiences. And choice B here is saying digital twins are primarily about providing the right data to help solve a problem. So again, preference, no right answer. I'm going to talk about both of these. But for those in the room who are saying the answer is B, raise your hand. Okay. B, yeah. So I would say about 80% of the room. So you make my life easier. It's not necessarily the correct answer, but I think the overall theme that we're going to be talking about here today is how we start to define digital twin, not from the ground up as a 3D model, but rather by the use cases themselves. So it's very critical when we start talking about digital twins that it's inherently about solving a use case. And the data that's necessary for that use case to be solved might not even be 3D, right? It might actually just be a 2D map. However, it solves that business problem. Obviously, here we're talking about 3D visualization. We had a morning of CityEngine, so we will be predominantly talking about how digital twins can be both of those things, both 3D immersive experiences, but also a means to solve a true business challenge. So those experiences, like you see here, this is built with the Maps SDK for Unreal Engine. This is a mesh of Utrecht. But as we start to integrate this new data, like reality meshes or semantic models that a lot of cities now just have, you know, the way we experience that data is changing. So these kind of, let's say, even if it's a one-off experience that is all about just flying through the mesh. I mean, this isn't, this is incredibly useful because it actually demonstrates the cutting edge of what we should be expecting to experience our data, or how we're expecting to experience our data. This is what's changing. It's not necessarily the data itself that is necessarily changing. So digital twins, they got their start, you know, in manufacturing and healthcare. You know, when we think of a digital twin, we think of aeronautical engineering, and you're taking a jet engine and trying to figure out if it'll break before you actually build it because of millions and millions of dollars and millions of people who have to fly with these engines in those planes. So really there is a risk that digital twins are trying to overcome by being able to predict an outcome with a certain level of certainty. And we do that all the time in planning. However, you know, obviously with scenario planning especially, we're trying to deal with many different alternative outcomes and try and come up with strategies around many of these things that aren't necessarily right or wrong. Here, it's more, will it break or not break? but I think it's more about performance, and same here when it comes to cities. But they're not highly engineered systems, so when we talk about digital twins in our industry, be it geospatial or planning, we really have to consider the fact that this is very hard to describe at the end of the day, right? And when it comes to the city, we're really talking about maybe multiple digital twins coming together in a way, because digital twins for the built environment, or urban digital twins, kind of got their start in the AEC sector because you have to have that certainty about risk at the site level. But now that we start to see the data that used to be just at the site level start to be city level and even regional level, we start to also consider that maybe there is some uses of a digital twin that go beyond just the site, and making sure that our buildings don't fall down, but also that walls don't intersect with utility lines, right? And windows, while they can intersect a wall, a gas line should not, right? And so there is a true tangible need for digital twins at the site. So when we think about the city, we really want to start looking at how we can answer questions, create value through answering obviously difficult questions that maybe only certain captures of the city, like this reality mesh, might provide answers to. Answer big questions, right? Answer small questions often. So being able to implement a sort of systematic use of the system. So just speaking about sort of the base capabilities that we're talking about here when it comes to GIS and ArcGIS, this is that reality mesh in a scene viewer. So everyone knows we have a map viewer and a scene viewer. The scene viewer is a 3D map. Essentially, you're taking the base map, whether it's semantic or a mesh, and you're starting to integrate and overlay your data on top of it. So when we think of the technology itself, the 3D capabilities that are on top of that are really building off of the data that you already have. So you actually, here you can see the integration of a Revit model published right from Revit to IFC, and then hosted here and merged into the mesh. So this underlying technology allows us to take a lot of existing data like 2D polygons and create a semantic model with the mesh. So here we're actually draping the polygons on the mesh, or we can start to mash up different data layers together. Some important use cases arise when we start this, right? You're talking about data that's already being managed in cities, like utility information, which might already have Z values on all of the different nodes of each pipe. And we can start to actually use the mesh to give context to that existing data that might be stored in Excel. So here you also see the mesh, and that concept of overlaying existing data like floors. In this case, it's a Z-enabled polygon with a little extrude on it. But this allows us to look at the mesh and click on the mesh. It could be even fully transparent, and you wouldn't even know that other layer was there. You'd just be clicking on the mesh. So these kind of experiences can start to be pinpointing the actual application or use case. So here you see crime. We can start to investigate, the model as it relates to real-time data as well. And here you can see the mesh and application in urban planning. So this is export coming from ArcGIS Urban that's then read in Unreal Engine with that same data. So you probably talked a lot about that in the morning session, but being able to take that kind of data and content out to even more immersive environments like Unreal Engine is super important, because there is an expectation from a lot of our users. But the expectation starts here. So when I think about the technology, I never go straight there. A lot of our customers get like, let's say, enamored by the reality mesh because it's beautiful at the end of the day to see your own city. But I think more and more there is an understanding of being able to prescribe data rather than go straight to the data as the digital twin. So rather than go towards the narrow definition of digital twin as a 3D model, all of us here in the room now know that there are use cases that we need to identify first. These are some of the ones that we've been working with the most at Esri. And today we're obviously going to be going into the spatial planning case in more detail. There's also a sort of, let's say, path that a lot of our users take when looking at their digital twin. And it really is, at the end of the day, aimed at those applications to support those use cases. But at the same time, you have to capture data, you have to bring that data in, serve it out a certain way, right? And then make that data available, and then integrate that data with other third-party systems in order to then support those applications. So this is just a very simple diagram showing maybe a 1, 2, 3, 4, 5 step, but all steps don't necessarily happen all at the same time or are needed. But we see that a lot of our cities that we're working with, our consulting firms that we're working with, are really building on the existing geospatial data that they're maintaining today, and then looking at how they can integrate that into supporting future applications. So there might be more novel data sets like the mesh, but that can be then combined with existing data sets like street signs, like you see in the background, that then can be supporting someone out on the ground looking for that street sign. So ArcGIS is really a foundation for digital twins. When we think of the capabilities at Esri, we think of them in 4 different, let's say, buckets of capabilities, for lack of a better term. Content, so there are a lot of tools within ArcGIS to generate 3D, extract 3D automatically, and basically support all of the necessary workflows to maintain that at the end of the day. Visualization, you saw the scene viewer, but then that is usually, let's say, the heart of more advanced visualizations that would make use of other parts of our platform. And the visualization actually is also defined by that use case. And then you have analysis. So we support a lot of analysis of 3D data as well as 2D data, as you know. And then immersive experiences. This is the entire, let's say, capability area devoted to looking at how we can experience the data in a new way. So when we think of ArcGIS and how it supports planning and urban design, obviously there's, like, let's say, the classic view on that. And so this is just, let's say, a look on how that might be. So at the very base, you have the integrations. So typically we look at what data is available and what data can we integrate with. It might be external systems like Revit, coming from BIM 360, Esri hosted data sets because we have global elevation, and then other data sets like IFC or CityGML that might already be available, depending on where we're building up that digital twin. And then with that, we abstract that data into servable layer types. This is done through either enterprise or online, or it could be done in ArcGIS Pro and managed in ArcGIS Pro, but served out as reusable web layers. Then there are the standalone viewers, which are map viewer and scene viewer. And there's, let's say, much more we would consider the foundational platform. There's then the application ecosystem. And so at that level, we really talk about which applications are best suited to support which use cases. And those use cases are at the top level, which are very much related to the users. So at Esri, we actually build these applications to both support a general set of users, but also very specific to planning, for example, or to urban design, or towards open data and data sharing. So these are what we would call like the business application tier. But that wouldn't necessarily be the tier where you host the data or integrate with other third-party sources. So it's a very useful abstraction of basically the platform that would support a digital twin for planning. I can show you a couple of examples now before I hand it over to my colleague to talk to you more about one of these products in particular. When we talk about the platform, there's probably no better example than Prague. Prague actually has been in the forefront of 3D city modeling for a long time. So they've served out a lot of their data on their geoportal. Their geoportal is both organized based on applications as well as the data. And so here you're looking at the 3D city model of Prague, and you're able to quickly navigate, obviously, and investigate by clicking on the semantic model, but also you can turn off and on very useful information like the underground technical utilities, whether it's telecom, electricity lines, water lines. So here you actually have a good sense of where these are before you start digging at the end of the day. One of the top use cases, honestly, in how you use 3D data effectively. They also have very customized applications using the JavaScript API. And again, it's not 3D, but it's certainly a digital twin because it's showing essentially what is being built and where. And you can see here all of the different plan areas of the city. And they use the 3D model to actually judge and review different design submissions that might be happening, ongoing throughout the city. So when you see 3D in ArcGIS, it might be a 2D layer that's represented in a 3D view. That doesn't necessarily mean it's 3D. When we think of 3D in ArcGIS, we're really thinking about buildings, about a mesh, or about a point cloud. These are 3D layers, and we have a technology called i3s, and this is an OGC community standard. And this i3s layer allows us to actually both import, right, and then stream out that 3D information. So when we think about i3s, we often think about 3D objects. This can come from GLTF, Collada, OBJ, FBX. This can be imported directly into the layer through the web browser, for example, or you can also import directly into ArcGIS Pro, right, as a scene layer in Pro. This is also going to be supporting 3D tiles come November, which is another open standard, similar to i3s. And together they basically are, the two OGC standards for serving out 3D information. CityGML, we also can export CityGML into ArcGIS Pro and serve that out as 3D object layers, which is essentially what you saw in the Prague base map. So those buildings are CityGML buildings, but being streamed as an i3s 3D object layer. And so this streaming can happen in the web, it can happen in game engines through SDKs, like the example earlier, or it can be exported as the model that it might have come in as, which is also a key use case, being able to get data out, for example, downloading a part of the city. If you are working with CityGML, we have a live survey, so especially those on the recording that might be watching, we'll keep this open, and we'd love to hear sort of where you'd like to take CityGML, because we realize that this is a true, let's say, open source standard that a lot of cities are using today, and ArcGIS is looking to obviously handle it and support it in a better way, both from serving it out, but also maybe managing it. So we'd like to hear your feedback and learn more about how you're working with CityGML today. So getting back to this diagram, now I'm going to kind of zero in on just this part, which is all the examples that you're about to see utilize these two components, ArcGIS Online and ArcGIS Urban, which is what the afternoon is really about. And those folks that I'm going to be showing in these case studies are generally the GIS teams, the urban planners, the planning architects, those doing urban design, and other 3D visualization experts. And so just so you know, that's basically just one piece of a much bigger platform. ArcGIS Urban, we launched it 4 years ago, almost today. And it's exciting because it's basically taking a lot of this capability that we've had in the desktop for a very long time and making that available through a focused experience for planners. And it's truly novel, I mean, on the web. So we're talking to a lot of our customers about using it for development review. So we take in developer models during the pre-application review of a building permit, and you drop that model in context, and then you can manage the versions of that model and start to analyze those versions for example, whether or not they cast enough shadow or not enough shadow, on surrounding buildings, for example, shown here. So as IFC models become more and more the standard for architects to submit their designs to city governments for review, the more our customers in the city are going to need tools like this to aggregate these Revit models and these, IFC models together in order to actually review those documents. So really going beyond PDF at this point. Then you also have in Urban what we call plans, allowing the ability to go in and understand what regulations can produce in terms of a build out of a certain area. So we can start to illustrate different alternative potentials, or if you're like in the development or real estate area, you call it exploitation of an area, because of Urban's ability to now model both the built form, like you see here in a very schematic way, but also the regulations. You're able to take the approach one or the other. You can start to look at master planning areas, but you can also start to look at the regulations themselves and start to model out what's potentially possible based on underlying regulations like height and floor area ratios. And then we can start to look at this information all together. So one important aspect is being able to load all plans within the city. And what you're seeing here is all of the potential housing across the city and where that housing is going to be coming from. So this data model that we've designed for ArcGIS Urban around plans and projects allow us to understand what's being planned and what's being built and where in the city. So the first example I'll show you here is actually coming from Sweden. It's Karlskrona commune. They are using ArcGIS Urban for what is called in Sweden detail plans. So here you can see ArcGIS Urban. We have plans. There's actually two types, land use plans and detail plans. And then you have projects, and projects are going to be the individual architectural models that represent potential new buildings that will get built. So when you open a plan in ArcGIS Urban, it actually enables a few foundational layers, and then also across the top you can see a series of scenarios. These are future buildings, and under those future buildings you have the regulations, and these regulations allow you to show the potential for a site, right? So here we're talking about a maximum building height, for example. And then the future building allows us to then quantify, if we were to build this many floors, how many apartments may we get, or how many jobs might be produced. And there are tools to actually fine-tune exactly what the massing might be within that regulatory envelope. So within Urban, we have these detailed descriptions of the space use types. They're defined even further than colors by the actual parameters, like how many apartments per square meter. And there are tools inside of Urban to also analyze both subjectively, as if you were on the ground, looking at side-by-side with Mapillary, which is an open source street view imagery, crowdsourced street view. And you also have tools to actually quantify things like the shadow. So how many hours are going to be in the shadow over a period of a day. And you can start to compare different scenarios and then look at that effect across maybe different decisions in terms of higher or lower building height. I mentioned the space use types are allowing us to track number of households, number of jobs. This can all be investigated as well and is customizable. So it's really depending on the plan. And depending on that type of plan, you might have different metrics to track different statistics about that plan. And then if you do work with a consultant, you can drop this in. It's usually based on the schematic model at the end of the day. It's downstream, but the illustration that you see here can easily be done in CityEngine, right? And dropped in for the visualization to the public during consultations. More advanced case. So I did want to show this because it's a rather new blog you can access. It's publicly accessible. The link's right there, but you can also just search CSTAT. CSTAT means city by the lake, I believe, or sea. It's in Vienna, so they're not near the ocean. But this is one of the largest developments in Europe at the moment. And so it doesn't happen overnight. It happens over a long period of time. And so they're actually using ArcGIS Urban to model out the plan as what it is today, which you can see in the mesh, but then model out the entirety of all the phases of the plan as they were designed. And so using Urban, you actually have that overview, but then within the plans, you have the ability to modify the districts of that larger master plan. So in this case, you're looking similarly to the other example. Each color represents a space use type, like apartment housing. But they actually took it a bit further, and what you see here is the dark orange represents building standards today, and then the light orange represents future building standards that are going to be improved. And they use this to assess their carbon for the district that you're seeing here, and then they're looking at how they can best meet their carbon budget by assessing that on the fly, both operational as well as embodied. And so each of these space use types now gets an amount of carbon. So you're able to obviously build dashboards around this and start to make those strategic decisions about how that plan will build out over time and include the improved building standards that would be implemented maybe even 20 years from now, right? We just don't know how we're going to be constructing our buildings differently. And this type of model, it's actually just an aggregation point for lots of people within that, that project to then reference. Yeah, Nottingham City Council, it's in the UK. Here you see a model of the entire city and all of the different development models that have been submitted overlaid on top. So each of these projects represents essentially what will become or should become a building permit, but during the pre-application phase, meaning there's still a consultation with the city to help that developer understand whether or not they can build that high or that much. There's also all of the plans here that you saw in the image that I showed earlier, and what we call indicators in urban are where you can actually store those snapshots of the entire city, essentially. So in this case, you're looking at an indicator showing the housing provisions from each of the individual plan areas that can then be interacted with. So really that overview mode is those, it might be for those that don't get involved on the individual plan scale, but they would still need to be able to interact and understand the overall impact towards the housing goals for the city. Here I can open up a project. So similar to plans, projects are going to have a set of tools and are going to be stored in ArcGIS Urban in a way that allows you to then open them up individually and work with them. So in this case, you see an LOD1 model, which is used for sharing, but then a detailed model. And in this case, it was it looks quite much like a model that was exported from a BIM software, alongside more conceptual models that come from the larger master plan. But this allows us to take a high resolution reality mesh and the high resolution coming from the BIM software dropped in as Revit, and we can start to use that within analysis together. So again, it's similar to what I had shown earlier in that image, but all of this is actually done in real time. I don't know if anyone's tried to do a shadow analysis in the past in ArcGIS Pro, you know, where you had to string together a lot of GP tools, but this doesn't need to happen anymore. A lot of these analysis can be done on the web in real time. Yeah, and then I'll close with this example, which is actually showing where we're going, which is towards making how we experience this data a whole lot more immersive. So we actually have an ongoing project here, just over in the other side of the room here for the recording. It's down the hall to the left. Here you're actually seeing the ArcGIS Urban data layers, the plans and projects being streamed into ArcGIS, into Unreal Engine. And this is a game built with Unreal Engine, allowing us to expect a project and then the scenarios that are associated with that project, and then the viewpoints that are associated with that project as well. And it allows us to actually put ourselves on the ground. So the reason why we're looking at doing this is obviously because all of this data exists and is streamed out, and we just want to read it and start to work with it and visualize it rather than build a game from scratch every single time. So this is really taking how we experience plans and the resulting scenarios to a new level. The team is also working obviously hard on looking at streets and how we visualize streets within these more schematic, sometimes schematic plans as well. So we can actually feel what it's like to be a biking down the street and assess densities. It's quite a large plan in Boston, but it is a real plan. Here you can see the integration with metrics. So the same dashboard, right, but streamed in to the game engine environment. And if you're using a headset, it basically looks like a giant panel beside you, which is really immersive when you try it. Yeah, with that, I think I will wrap up and hand it over to my colleague Silvia to tell you a bit more about our roadmap. Thank you. Sure. Yeah, are there any questions?
I was curious about the indicators. Is there any feedback provided by the indicators that will tell you recommendations for things that might be an indicator of concern for the development?
Yeah, it's a good question. I guess I don't have to repeat the question, right? So that's captured. Yeah, so the indicators that I was showing, let's say, are more reports. being aggregated from many different plans that might be across the city. And I think what you were referring to is more, let's say, have an overview of where to target an action such as a new plan. Therefore, an indicator might be heat island, and you want to select the areas that maybe should have improvements made to improve the heat island, or let's say get rid of it by adding more trees. That type of use of indicator is not yet in the software, but we've been hearing a lot about it as a potential use case. But at the moment, really, it's going from the plans to maybe a larger look at those plans rather than the other way around.
Okay, and one other is just, has anyone approached you about emergency scenarios for urban as a product, or maybe response, emergency response?
Not yet, actually. So if you have a case around that, I think it would be really interesting. But yeah, no, at the moment, the idea of planning maybe a campus or an event, or even maybe a temporary shelter area, these use cases obviously are related, but not necessarily explicitly supported by ArcGIS Urban. So we'd be interested in hearing more about the case, I think, and seeing if, maybe it'll work for it right out of the box. No changes needed, but maybe not. And I would say we haven't necessarily built ArcGIS Urban to handle planning an event, right, or planning a temporary shelter area. But I think that would be an interesting place to explore new use cases.
Just thinking about the hot maps, like the OSM hot maps, if there's a way to plug that in and see if it has an impact in the software. So, okay, well, thank you.
Sounds good.
There are other products that are dedicated for emergency management.
So there are other products in the suite of 1,000 products that Esri has that are for that. But is your need for managing emergencies in 3D?
Can't speak on need, but I'm just curious.
Okay, because like that's a different requirement, right? Like when you have to go up a building and find a route and things like that. Might not be for urban, but I'm asking for my friends, my other PM friends, you know? Yeah, okay.
All right. For those on the recording, feel free to reach out to me by email. It's on the first slide. Happy to answer questions. Thank you.